Assalamu alaikum viewers. Today we are going to discuss about the concept of ionization energy. Like atomic radius, this ionization energy is also an important periodic property of an element. As you know that in an atom, the electrons revolve around the nucleus in the circular paths, and those circular paths are known as shells or energy levels. So electrons are revolving around the nucleus. Say these are our electrons, and they are revolving around the nucleus in these circular paths, and those circular paths are known as shells. These electrons are negatively charged and the nucleus is positively charged. Now these negatively charged electrons are held to the nucleus by the help of a force of attraction. That force of attraction is known as nuclear force. So we can say electrons are held with the nucleus by nuclear force. Now in order to remove this electron, that is the outer electron from the nucleus, this nuclear force is to be overcome, and this nuclear force is overcome by the help of an energy. And that minimum amount of energy which is required to remove the most loosely bound electron from an isolated gaseous atom is known as ionization energy. So we can define ionization energy as the minimum amount of energy or required to remove the most loosely bound electron, that's outermost electron, from an isolated gaseous atom. Now in order to explain the ionization energy, let's consider an isolated gaseous atom, that is X. Say X is the isolated gaseous atom. Now if we supply the ionization energy to this X, by help of this ionization energy it loses the outermost electron, so it loses electron. And when a neutral gaseous atom loses electron, it results in the formation of a positive ion, that's X positive. So X positive is the cation. Hence we can say that by supplying the ionization energy to the neutral atom, it changes into cation. So ionization energy results in the ionization of an atom. Hence we can say that the tendency of an atom to form the positive ion, that's cation, depends upon the value of ionization energy. That is, thus the tendency of an atom to form the positive ion depends upon ionization energy. That is, if the value of ionization energy is more, less will be the tendency to form cation. So we can say that if the value of ionization energy is more, less will be the tendency to form cation, that is, less will be the tendency to lose electrons. So the tendency of an element to form cation or the tendency of an element to lose electron depends upon the value of ionization energy. So this was about the ionization energy. Units of ionization energy, that is IE. Generally this ionization energy is measured in the units of electron volt per atom or kilojoule per mole. So these are the units by which we can measure the ionization energy. And it must be noted that 1 electron volt per atom is equal to 96.49 kilojoule per mole. So now we will discuss about the successive ionization energy. Successive ionization energy. Now once the first electron is removed from a neutral atom, it is possible to remove the successive electrons, that is second electron, third electron, fourth electron, and so on, from this neutral gaseous atom. And this ionization energy which is required to remove the first electron, second electron, third electron, and so on from these neutral gaseous atom is known as the successive ionization energy. So successive ionization energy is used to remove the successive electrons from an isolated gaseous atom. For example, if X is a neutral gaseous atom, by supplying the first ionization energy, that is IE1, it loses first electron and results in the formation of X positive, that is unipositive cation. And when this unipositive cation is provided with the second ionization energy, it loses the second electron and results in the formation of dipositive ion. That is, if X positive ion is provided with second ionization energy, it loses the second electron and forms dipositive ion. Similarly, if this dipositive ion, that is X dipositive, is supplied with the third ionization energy, that is IE3, it loses the third electron and results in the formation of tripositive cation. So we can say that the ionization energy which is required to remove the electron from the isolated gaseous atom that was neutral is known as first ionization energy, and the ionization energy which is required to remove an electron from the unipositive cation is known as second ionization energy, and the ionization energy which is required to remove the electron from the dipositive ion is known as the ionization energy third, that is IE3. So we can here say that the value of ionization energy required to remove an electron from neutral gaseous atom, unipositive ion, dipositive ion, and so on, is termed as successive ionization energy. So this was about the successive ionization energy. Now we will discuss about the factors which affect the ionization energy. So factors affecting ionization energy. Now factors affecting ionization energy. Students, it must be noted that the value of ionization energy depends upon four factors. That is the size of an atom, and second one is magnitude or amount of nuclear charge, magnitude of nuclear charge. Third one is screening effect, and fourth one is electronic configuration. So let's discuss about the first factor, that is size of an atom. Students, it must be noted that the size of this atom represents the distance between the outermost electron and the nucleus. Now, more the size of an atom, that is more is the distance between the outermost electron and the nucleus, so less will be the nuclear force. So more the size of atom, less will be nuclear force of attraction. और जब न्यूक्लियर फोर्स ऑफ अट्रैक्शन का वैल्यू कम होगा, it means we have to require a small amount of energy to remove the electron. So less will be the value of ionization energy required. Hence we can say that more the size of atom, less will be the ionization energy. Thus, with decrease in atomic size, there is increase in ionization energy, and vice versa. For example, among the periodic table, the first group of elements, that is alkali metals, have the highest atomic size, so they have the minimum ionization energy. So alkali metals have minimum ionization energy in the respective period. So hence we can say that these alkali metals have the maximum tendency to form the unipositive ions, and hence these alkali metals are electropositive. Now, second factor is the amount of the nuclear charge or the magnitude of nuclear charge. Magnitude of nuclear charge. First of all, the magnitude of nuclear charge depends upon number of protons in the nucleus. So more the number of protons, more will be the nuclear charge, and hence more will be the nuclear force. और जब न्यूक्लियर फोर्स का मैग्नीट्यूड ज्यादा होगा, more will be the value of ionization energy required. So we can say that the value of ionization energy increases with increase in the magnitude of nuclear force. That is number of protons. For example, in a given period of a periodic table, the magnitude of nuclear charge, that is the number of protons, is more for the noble gases. So hence, in periodic table, noble gases represent a group of elements with maximum value of ionization energy. So noble gases have maximum value of ionization energy in a respective period. So students, in this topic we have discussed about the ionization energy and the first two factors, that is the atomic size and the magnitude of nuclear charge, on which the ionization energy depends. And in next lecture we will discuss about two more factors, that is screening effect and the electronic configuration, and also we will discuss about the trends of this ionization energy in the periodic table. Till then, thanks and have a nice day.